All right, y'all, FSA page 21, we did it. This is our last page. We're going to be talking about line of best fit and residual plots and correlation coefficients. So let's get started. Is y equals 2.6x plus 2.6 a good fit? So this is these are the points that we already have, and we want to see if this line is a good fit to these points. So we're going to fill in the table and create a residual plot. So what I'm going to do, because I already have the observed points, what I want to do is find out what this line would look like. So all I'm going to do is plug in these x values to this x right here. So 2.6 times 0 is 0, plus 2.6 is 2.6. This is a 2. 2.6 times 1 plus 2.6 is 5.2. When our x is 2, we have 2.6 times 2 plus 2.6 is 7.8. And when our x is 3, we do 2.6 times 3 plus 2.6 is 10.4. Now to find out if this line is a good fit for these points, we're going to look for our residual amounts that are left. So basically I'm going to subtract my observed value minus my predictive value, gives us our residual value, or the difference between what we observed and what the line would actually be. So 4 minus 2.6 is 1.4. 3 minus 5.2 is negative 2.5. 8 minus 7.8 is 0.2. And 11 minus 10.4 is 0.6. And now what I'm going to do is create my residual plot, and basically if my y values and my x values that's right. So my x values are going to be my x values, my y values are going to be my residual values. So if my x value is 0, my residual value is 1.4. If my x value is 1, my residual value is negative 2.5. If my x value is 2, my residual value is 0.2. And if my x value is 3, my residual value is 0.6. So what we want is for these points to be pretty evenly distributed above and below this line and be as close to this line as possible. So I actually would say that this line is a good fit. Moving on to number 2, match the appropriate correlation coefficient to the scatter plot. Pause this video and please Google what is correlation coefficient. Basically what the correlation coefficient is how these dots compare to if you were to draw a line through it, a line of best fit. So a correlation coefficient of 0 means that no straight line would work. And a correlation coefficient of positive or negative 1 means that the dots are exactly on the line. So for example, this guy, I couldn't draw a line anywhere through here and have the dots near the line. So this has a correlation coefficient of 0. This guy, I would probably draw a line right about here. And these dots are pretty close to the line, but they're not right on the line. And this is slanting upwards. So this is a positive 0.3, positive 0.3. This guy, I would draw my line right here. Oops. And I would say that these dots are pretty darn close to my line, if not right on my line. It's more of a me drawing error than a line error. And this is pointing down. So this is going to be a negative 0.9, negative 0.9. And these dots are pointing upwards, and they're pretty darn close to the line, if not right on the line. So this is a positive 0.9. And now this graph is kind of pointing downwards like this. And the dots are pretty close to my line, but they're not like right on my line, so I'm going to say it is a negative 0.3. Moving on to question 3. Which residual plot shows that the function is appropriate to the data? So a residual plot is like what we talked about up here. It is how close these dots are to the line that they said. So what you want with a residual plot is dots that are pretty close to the middle line and are evenly spaced around it, which in this case would be this one. Because look how close these dots are to the line, and they're pretty evenly spaced towards it. Versus here, you have a kind of a line going through, so you could probably fit a better line of best fit. So number 4, why is this an appropriate fit? The residual dots are close to the line. The residual dots, sorry, my handwriting's not great, are close, I'm going to say to the x-axis, to the x-axis. And this actually is our correlation coefficient. So this would be like it has a correlation coefficient that is close to 1. Number 5, which of the functions is the best fit? So now we have a couple of options. We have 1/3 w plus 6, 3w minus 6, 1/3 w minus 6, or 3w plus 6. Well, the first thing I'm going to look at that's pretty easy is I see that my y-intercept is positive. So both of these equations that have a negative y-intercept, you can cross them off. They are not going to be our answer. And now all we need to do is find the slope. So if we were to draw this line up here, right? Boom. Here's my line, right? I can pick any 2 points on this line. I'm going to say right about here and right about here. Slope is rise over run. In this case, if I have a dot here and a dot here, I rose, notice my axis, from 10 to 15. I rose 5 over, I ran, it looks like 2. 5 divided by 2 is 2.5, which is much closer to 3 than it is to 1/3, which makes our answer D. So now what is a good estimate for the total distance he would run at week 15? So what we're going to do is plug it into this equation, right? D of W equals 3W plus 6. So if our W is our week, and we're talking about week 15, we're going to plug in this 15 for W. So 3 times 15 plus 6 is 45 plus 6, which is 51. And this is distance. I'm sorry, I didn't write the whole question, but I'm going to say meters? Sure. 51 is our answer.